All right, so today we're going to work on our second method of solving systems of equations. We're going to be focusing in on graphing. And we know that with systems, we actually have two equations. So what we're going to be looking for is two lines and where they intersect. Okay, so a couple of things as you're taking notes and working on things, make sure and use a straight edge. You want to draw as nice of a line as possible. That would be super helpful for you. And we're going to pull back many of our things from semester one, so solving for y and graphing. So let's go ahead and get started. Okay, so we've got two equations. We've got 2x plus y equals 2, and we've got x minus y equals 4. And we know that to graph, we need y equals mx plus b, where b is our y-intercept and m is our slope. So let's go ahead and solve these for y. So if I start with my 2x plus y equals 2, I know that my y needs to be alone, so I'm going to subtract my 2x, and I come up with y equals negative 2x plus 2. And as you remember, the first number is my slope, so that would mean my slope is negative 2 over 1, and my b is 2. So I'm starting at 2, that's my y-intercept, so I'm going to go up 2. And then since my slope is negative, I'm going down 2, right 1, down 2, right 1, down 2, right 1, and I have a number of graphs there. So let me go ahead and try to draw a decent line through these points. Okay, so there's my first line. Let's go ahead and solve the other one. So remember, these are ones. So I'm going to subtract my 1x. I have negative 1y equals negative 1x plus 4. I need to divide by negative 1 because I need a positive y. So y is going to equal 1x minus 4. And remember, this is really 1 over 1. Okay, so that's my slope, and the b is negative 4. So I'm starting at negative 4. I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, and I can keep doing that until I am in a good location. Whoops, let me go ahead and make that a red line so we can see what we're looking at. All right. So we are looking for where those points intersect. So in this case, they actually intersect exactly on a point that I can actually tell what it is. Remember, that's a point of equilibrium. So that ordered pair, the solution to that system, is an x and a y. So remember, I'm going to check my x value and then get my y value. So I'm over 2 and I'm down negative 2. So that solution is 2, negative 2. Okay, it's 2, negative 2. All right, let's take a look at this one. Take a minute, hit pause, and go ahead and solve for y. Solve for y. All right, so I know that to solve for y on this one, I'm just going to have to add my 2x. So y equals 2x minus 6. That gives me a slope of 2 over 1 and a b of negative 6. So I'm down at negative 6, and I'm up 2 over 1. Again, I can make multiple points, and I can draw a nice straight line through those, and make sure that you draw the line fully across the graph. Don't be making your line short. We actually need to have that full distance in case our line intersects someplace that's not in the middle. Okay, now this one, when I'm solving the blue one, remember that is a negative 1. So 2y, if I add my 1x, then 2y is going to equal 1x plus 5. Remember, these are not like terms. They're just going to drop. Dividing by 2, y equals 1/2 x plus 2.5. So this one is going to be an estimate because 2.5 is not an exact point. Okay, so 2.5, I'm up 2 and a little more. So there's my starting point. And I'm going to go up 1, right 2. So up 1, right 2, up 1, right 2, up 1, right 2. I'm someplace in this vicinity. Need to make a blue line. So blue line coming through here. Okay. So my point of equilibrium is here. Now that is an estimate because I can see that there's no way that I can tell exactly where that is because it's not exactly at 2.5. It's not exactly at, or it says not exactly at the 6, and it's not exactly on the 5. So I'm actually kind of in the middle. So I'm going to estimate that to be 6.5 on my X, and I'm going to estimate that to be 5.5 on my Y. Okay. Now here's the one thing that we have to realize when we are solving systems. When we are solving systems graphically, okay, so in other words, we're graphing the lines by hand, it is always going to be an estimate because we are not precise. I mean, I'm a pretty good artist, but we all know that is probably going to be off by a little bit. Okay. And so it's an estimate. We're just going to be close, and that's okay for our purposes today. As we move forward, tomorrow we're going to take a look at using some technology to help us graph, because if we want to have an exact value, we either need to solve it algebraically or we need to use technology to help us graph. Okay. And we're going to be making use of the Desmos graphing calculator tomorrow to graph accurately and find those intersection points. Okay, let's take a look at one word problem, and so we can try to figure out the meaning behind an x and y solution, the intersection. What the point of equilibrium means if I'm talking about a word problem. So remember, we're talking about standard form equations. Ax plus by equals c, which means we're going to have something x plus something y. If I can make that go backwards here, plus something y equals a total. So something x plus something y equals a total, okay? And let's start by defining our variables. Let's read this. So Brenda's school is selling tickets for a senior class musical. And on the first day, the school sells 3 senior citizen tickets and 9 child tickets for a total of $75. The school then took in $67 on the second day by selling 8 senior citizen tickets and 5 child tickets. What was the price of the senior ticket and the child ticket? All right, so if I pay attention to what comes first, I know that the X are the senior tickets and the Y is the child. Okay, we've got two equations. We've got 3x plus 9y equals 75. And we've got 8x plus 5y equals 67. All right, go ahead and solve for y and get those lines graphed. All right, let's see how we did. So I'm going to subtract my 3x. I have 9y equals a negative 3x plus 75. I'm dividing by 9. I have y equals negative 1/3 x. Remember, math frac or simplification on your Desmos calculator is your friend. 75 divided by 9 is going to give me 8.3. So again, this is going to be an estimate. So if I'm graphing this, I'm starting at 8.3, which is a little bit more than 8. So I'm going to put that right there. And I'm going down 1, right 3. So someplace in this vicinity is my first line. So go ahead and get that graphed. Okay, that's not too bad. It's a little bit off. A little bit crooked. Okay, that's pretty good. All right, let's solve the other one for y. So minus our 8x. Again, same process. Move your x, divide by your y. Negative 8x plus 67, divide by 5. So y equals negative 8 over 5x, and 67 divide 5 is 13.4. So I'm starting at 13.4, which is up here. And I'm going to go down 8. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4. And I'm going to go ahead and draw that line. And again, we're looking for where they intersect. So this is an estimate. We're going to get as close as we can. Can get it to rotate just a touch. Okay. All right, so in looking at this, I am going to assume that this is my intersection right here. Okay, it looks like that's where they intersect. So my point of equilibrium, we're going to estimate to be, if that's $3, I'm a little bit more than 3, so I'm going to say 3.25 for my x, and I'm going to come up to my y, and I'm going to say that is pretty close to 7. So I'm going to make it a 7. Well, what does that mean? What does that mean? Well, remember, we're talking about senior tickets and children's tickets, and they want to know the price. Okay? And my X are the seniors, and my Y are the children. So this appears to be that we have a price of senior tickets of $3.25. And a child ticket is going to be $7. Now, is that exactly perfect? Nope, it is an estimate. We graphed those. So remember, as we're graphing by hand, it is an estimate, and you are looking for those point of intersections. And make sure and use your rulers. Since we're using technology to kind of help you draw, your estimates will probably be a little bit better than the ones that I would have because I'm drawing by hand. Work on your homework today. Let us know if you have any questions. Tomorrow, we're going to work on using technology to actually come up with those values exactly. To find those solutions, and we'll kind of go from there. So have a good rest of your day. Reach out to us if you have any questions.